Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos.
Anyways, today in this particular lecture, we will going to discuss about the introduction about your source coding. We basically try to get the intuitive insight about source coding, what it is and how we are actually supposed to do that. So these are the outlines. We're going to start up with the introduction. Then we will going to describe what is source coding, which will be followed by the intuitive discussion about source coding. Then we will going to try to understand the source coding via some example. So in our earlier lecture, what we have studied about, we have already discussed the basics of information theory. That is, what is information, what is the information content. We have also discussed about the average information content of a binary symmetric source and the average information in a message, such as your entropy. So now in this particular lecture, we will try to understand that how we will be going to generate a digital signal, or you could say your bits, against the symbols which would have been generated by your different information sources. So the basic insight is how we will going to generate bits corresponding to the different symbols generated by your information sources. So next question that arises is, what is source coding? So a conversion of the output of a discrete memoryless source into the sequence of binary symbols, that is binary code word, is called as your source coding. So our discrete memoryless source is basically generating different symbols, and distinguished symbols are not at all dependent upon the occurrence of other symbols. So that we have discussed in our earlier lecture about discrete memoryless source. So your discrete memoryless source is basically generating distinguished symbols, and idea is to generate different bits corresponding to individual symbol levels. So that particular process would have been called as your source coding. So basically the device that perform this particular operation or conversion, that would have been called as your source encoder. So the output of the encoder is basically in terms of bits, which would have been generated against the different symbols generated by your information source. So now we will try to grab the fundamentals of the source coding via some of the examples, that is what we meant by that source coding and how we will going to do. So the exact process that how we will going to perform it in terms of your Huffman coding or Shannon-Fano coding, that we will going to study in our upcoming lectures. But in this particular lecture, our whole focus is just to get an intuitive knowledge about your source coding. So source coding, it is intuitively reasonable that an information source of entropy h needs on average only h binary bits to represent each symbol. This we had already discussed while discussing your entropy, which is nothing but your average information content of your message signal. So h are the average number of bits which are required on an average of the information of that message. So the equiprobable binary symmetric source, which will basically going to generate only two outcomes. So it will basically going to generate one information bit per symbol, or you could say per outcome. We had also discussed some of your binary symmetric source in terms of weather forecast, where it is generating basically two types of outcome. What will be the weather on a particular day, whether it is sunny or cloudy. So we will going to take up the same example in this particular lecture also. What is the objective of source coding? So the objective of source coding is to minimize the average bit rate required for representation of the source by reducing the redundancy of the information source. So basically we just have to reduce out the redundancy associated in your information source or the information generated by your information source in order to reduce the bit rate demanded by individual user. So since if we talk about your channel, we are using them on sharing basis. So what our objective is just to maximize the channel capacity so that more and more number of users will going to access that particular channel. If somehow we are in a state to compress or reduce out the demand of the bandwidth corresponding to individual user, then definitely that will going to serve the purpose, or more and more number of users will going to access or use the channel. So this is our objective, that is we want to reduce the redundancy involved in your information source or the information generated by your information source. So again we will going to considering the same example. Let us understand with one example that now the Lucknow weather forecast again. So we had already discussed that weather forecaster will going to give the weather forecast of a city Lucknow, that what will be the weather on a particular given day. So suppose the probability of cloudy is 0.1 and the sunny is 0.9. So that weather forecaster would have been considered as your binary symmetric source, which will going to generate two outcome, that is whether it is cloudy or it is sunny. So the probability associated with your cloudy, that is your 0.1, and the probability associated with your sunny, that is your 0.9. So this source has an entropy of 0.47 bits per symbol. We could easily count out like H is equal to minus Pi log of Pi. So that will be equal to 0.1 log base 2 0.1 plus 0.9 into log base 2 0.9. So that turns out to be 0.47 bits per symbol. So that is the average information of that BSS. So suppose we identify that cloudy with 1 and sunny with 0. So we are basically trying to map the outcome of cloudy as 1 and the outcome sunny would have been mapped as your 0. So this representation uses one binary bit per symbol. Fine. So one symbol is your cloudy or C and second symbol is your sunny or S. So for cloudy we are using this 1 and for sunny we are using this particular mapping, that is 0. So thus we are using more binary bits per symbol than the entropy suggests is necessary. So our calculation basically gives us the value of H, that will be equal to 0.47 bits per symbol. But the mapping that we have discussed, what we are actually doing is we are transmitting 1 bits per symbol. So we are basically passing extra redundant information which we need to minimize. So the actual bits per symbol information, that is our requirement, is 0.7 bits, but we are basically transmitting 1 bit. So basically 0.53 bits per symbol is quite redundant, or it doesn't have any information. So the whole objective is we have to reduce out or minimize that redundancy that would have been involved in this particular thing. So the replacement of the symbols, that is cloudy or sunny, with a binary representation is called the source coding. This we had already discussed. Then in any coding operation, we basically have to replace the symbol with a code word. This is what we have to do. And what is the need of doing that? Just because we have to process our signal in digital domain, and if we are using digital signal processors for the processing, then obviously we have to have some digital information in order to process. So basically the digital information source generates some symbols that we need to convert into the code word with the help of encoder, so that we can process the information in the digital domain. This is what we had already discussed. So what is the purpose of source coding? Although we had already discussed that the sole purpose is to reduce out the number of bits required to convey the information provided by the information source. So we just really have to reduce out the redundancy. Redundancy is some extra information which is not containing any actual information, but it is having certain extra information which are sometimes necessary to understand it. About the redundancy and how we're going to calculate it, we had also discussed in our last lecture. So if you have any doubt, you can go through that previous lecture first. So code words are not simply associated to a single outcome, but to a sequence of outcome. This is one of the most important point, that instead of performing the mapping of single outcome, we can use the sequence of outcome, which will further going to reduce out the redundancy. And how it will going to happen, we will going to do some example or calculation so that you have some better idea about it. So now let us consider the example. Here what we are basically doing is we are clubbing, or we are basically taking the outcome of 3 dates of the same BSS source, that is your weather forecaster, that is what will be the weather on 15th, 16th and 17th of July, and we are taking them simultaneously. So according to their probability and assign binary code words to these groups outcomes, we will try to find out the average information and the redundancy. So here this particular table is basically showing the variable length code. What is that? I mean, if you are talking about your variable length code, it means that different combination of symbols, that is your SSS, SSC or up to your CCC, these are the different combinations of outcomes, and the code word that we will going to use them in order to represent those sequences or group of outcomes. That is, here we are using 1 bit, and for this 4 sequences we are using 2 bits, and for last 2 sequences we are using this 3 bits. So all the code words will going to have different number of bits, so that is why we are calling them as your variable length code. So here this particular figure is basically showing the probability associated with the group of sequence of outcome. That is, what will be the probability associated when on 15th, 16th as well as 17th of July, all 3 days we will be having this weather sunny. That will be equal to 0.729. For 15th it is sunny, 16th it is sunny, and 17th it is cloudy. What will the probability of that? That is your 0.081. And similarly, what will be the probability that on all 3 days, that is your 15th, 16th and 17th, we will be having this cloudy? That probability will be equal to 0.001. Here this is just a single probability assignment, and what we are intentionally did is, for high probable event we will be assigning smaller code words, since the probability of occurrence of this outcome is much larger. So if we are using shorter length code word, then obviously we can save specific bits or some bits. So that is our sole objective. So it is easy to compute that this code word will on average use 1.2 bits per sequence. So how we will basically going to compute or evaluate the code which on average bits per sequence gives us? That will be equal to 0.729 times of 1 plus 0.081 times of 1 bit we are using for that. Then for these two we are using 2 bits, that is 0.081 into 2 into how many number of bits we are using? That is your 2, and 2 times we have taken, that is why we have put in this 2. Then for this 0.009 we are using them 2 times and 2 number of bits, that is 2 into 2 plus again 0.009 into 3 number of bits, and how many code words we have using? That is your 1 plus again 0.001, and how many number of code words we are using? 1, and number of bits will be equal to 3. So that turns out to be, it will simply going to gives us 1.2 bits per sequence. So this is basically the simple average. You can just evaluate it out. So on an average, for transmitting these symbols, we basically required 1.2 bits per sequence, and in each and every sequence what we will be having? We'll be having these 3 symbols. So if we basically have to evaluate the bits per symbol, so we just simply need to divide by number of symbols in the sequence. So via just dividing this 1.2 divided by 3, so we will be having this 0.4. So this is the average bits per symbol which is our requirement. So hopefully you get this calculation. So now using sequences decreases the average number of bits per symbol. This we had studied, or we have already evaluated, that on an average we will be requiring 0.4 number of bits per symbol, which was initially greater than 0.4. So we have found a code that has an average bit usage less than the source entropy. So this we had also evaluated, that value of h is larger than your average code word. So how it is possible? So we got it accidentally, or it is actually being possible? So the reason behind that, if we are clubbing multiple outcomes together, then that will going to gives us the basis to further reduce out the redundancy. So initially when we are taking 1 bits per symbol, then on an average we will be having this 0.47 bits per symbol. But when we have clubbed it out, we had already described that we are having this value of 0.4, which is lesser than your average value. So if we are taking the groups, then obviously we are in a state to further reduce out the redundancy. This is what we have observed. So but there is a problem with the previous code. And what is that? So before a code word can be decoded, it must be parsed. What do you mean by parsed? That is, we are in a state to specifically find out that where one code word is get ended up or where second code word is actually being starting. Just because for simple transmission reception process at the receiving end, we are just simply getting the bit streams of zeros and ones. So if we are not in a state to discriminate about different symbols, the whole communication process will be a failure. We are in a state to find out specific symbols distinguishedly. So parsing describes the activity of breaking a message string into its component code word. So it is basically certain activity, or you could say certain extra coding which will going to helps us to discriminate among different symbols. So after parsing, each code word can be decoded into the symbol sequences. And instantaneously parsable code is one that can be parsed as soon as the last bit of the code word is received. So as soon as last bit of the code word would have been received, then next parse sequence would have been started, so that receiver is in a state to discriminate that look, now next code word would have been started. An instantaneous code must satisfy the prefix condition, that is, no code word may be prefix of any other code word. So prefixing is a form by which we can employ our parsing to our code word. So here one should be cautious that no code word may have prefixes that is equivalent to another code word. So this is your prohibited condition. Otherwise that prefix and your parsing will get confused via it is your previous symbol or it is your next symbol. So this condition is not satisfied by our code that we had already discussed. The sequence of 011 could be your 0 #11, that is a complete sequence 011 is there, or first we will be having this sequences that is 0 and 11. So that is sunny 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 followed by the cloudy cloudy and sunny, or 01-1 that is either SCS followed by SSC. So there exists ambiguity into it and we are not in a state to distinguish multiple code words. So hopefully you all have got some idea about your source coding, what intuitively it is, and how we should form such sort of coded sequences against different symbols generated by your information sources. So parsing is also one of the important factor, just because without parsing we are not in a state to distinguish among different symbols or code words. So that basically forms the basis of understanding this source coding. So in our upcoming lectures, we will try to discuss how we basically going to perform this source coding, that is your Huffman coding or your Shannon-Fano coding. But before that, we must have to understand few nomenclature about your source coding. So hopefully in our next lecture soon we will going to discuss about specific definitions or nomenclature associated with your source coding, which will be followed by your different source coding mechanism such as your Shannon-Fano coding and your Huffman coding. So hopefully you have got the point. In case of any doubt, you can ask me in the comment section. I'll try to solve them as soon as possible. So these are the references, and thank you very much for your patient hearing.